Okay, this is the last video from section 5.8 through 5.10. This is test review part 2. So if you are watching this, it means we were, if this is 2021, you're watching this, it means we were not in school on Tuesday. So I'm going to go ahead and make the video just in case I have some sort of power outage. And we're going to do topics 6 through 10 on this video. So in section 5.9, all right, let's call this topic number 6, and that is inverse trig integration. And you're just going to use the handout. So you'll want to have your handout handy. Okay, so in 5.9, all that we had to worry about were these 3 formulas here on the handout. So it's really just about pattern recognition. But one thing you got to be really careful of is that you must use U substitution if du does not equal 1. All right, so I'm going to go ahead and give you a couple of examples where that is the case. So let's say we're going to integrate 1 over the square root of 9 minus 4x squared dx. Now what that looks like, if you look at your formula sheet, it looks like arc sine. So that's part of the battle right there. U is going to be, well, it's this. The u term has to deal with the variables. It's the square root of 4x squared, so u would be 2x. A is going to be the square root of 9, which is 3. So since du isn't 1, we're going to have to deal with that. So du is equal to 2 dx. All right, so 1/2 du is equal to dx. So we can rewrite this in terms of u. Put a 1/2 out front. You'd have 1 over the square root of 3 squared minus 2x, or u, however you want to write it, all squared dx. Okay, we better write that in terms of u. Sorry about that. You don't have to. So it'd be du, and then it'd be u squared. Okay, so looking at the formula, we've got the 1/2 out front. Don't forget about that. We know it's arc sine. And then it's u over a. Okay, so that's going to be 2x over 3 plus c. So the fact that we had to use u substitution, that du was not equal to 1, just changes the coefficient out front. That's pretty much what it does. Okay, let's do one more example on these. Okay, so this example is, let's say we want to integrate 1 over 5 plus 3x minus 2 all squared dx. Okay, so it's the one without the radical underneath, so that's going to be arctangent. A is going to be the square root of the number. Okay, so square root of 5. And then u is going to be oh, this is, we're not even have to think much here. It's just going to be 3x minus 2. So we have a du that's not equal to 1. It's going to be 3. So a third of a du is equal to dx. We can rewrite this 1/3 1 over square root of 5 squared, right, a squared, plus u squared du. Okay, so using the formula, it's 1/3, that 1/3 out front, times 1 over a, 1 over square root 5, arctangent, u, 3x minus 2, over a, square root of 5, plus c. All right, so you could clean this up and make that part 1 over 3 root 5, right? And then you'll just write all that again, Okay, so that is the 6th topic that we did. And before we move on, let me write one more thing. Write this in your notes. Don't forget definite integrals. That's where you have to plug the numbers in. Okay, so where you plug the numbers. Okay, so we would have, from A to B of something. You'd use your, most likely you would use the unit circle. All right, and get those numbers from that. So you had a lot of homework where you had to plug numbers in. So practice a couple of those. Okay, now let's move on to section 5.10. It had more topics. 5.9 was kind of the hardest section. So this would be hyperbolic. So what you had was, let's see, this, maybe I don't have 10 topics here. I don't know. I quit numbering, but I'm not going to give you examples here, but let's call this topic 7. You had the definition, and that was just plug numbers in. It's a terrible G. Plug in. And what I'm talking about there with the definition is where you plugged into the e's here. All right, so I'm not going to do an example of that, but you also had identities. So you worked a homework problem like that where you were given one of these and you had to find the other 5. So that's definitely in play. I think the example I had, hyperbolic tangent is equal to 1/2, and then you had to use this to find hyperbolic secant, and then maybe use this to find hyperbolic sine, and flip to find cosine. You had to go through all that. So you definitely might have to do one of those. Okay, so that's topic 7. Let's go to topic 8. That was derivatives. And you're just going to use the sheet. I'm going to repeat that mantra again and again. Use the sheet. So derivatives, hopefully this is still in your video screen, those right there. Let's do a couple of examples. So our first example is, let's say we have y is equal to hyperbolic secant 3x squared. Okay, y prime, this is going to be chain rule. The derivative of hyperbolic secant is minus hyperbolic secant hyperbolic tangent. So it's going to be minus hyperbolic secant 3x squared hyperbolic tangent 3x squared times the derivative of the block 6x. So we're going to clean that up, bring that 6x out front. Still have the negative. Minus 6x, hyperbolic secant, 3x squared, hyperbolic tangent, 3x squared. Boom. See if I can fit another example on here. Y is equal to e to the hyperbolic tangent 5x. So y prime is going to be e to the blop, e to the hyperbolic tangent 5x times the derivative of the blop. Okay, so that's going to be, what's the derivative of hyperbolic tangent? Okay, well, I don't know. Let me look. It's hyperbolic secant squared. 5x times the derivative of the innermost blop, so times 5. All right, so cleaning that up, that's going to be, let's bring the 5 out front. So this is going to be 5e to the hyperbolic tangent 5x times hyperbolic, let's move that up here. Okay, sorry about all that. Give myself a little more space here. So 5e to the hyperbolic tangent 5x times hyperbolic secant squared 5x. Probably would have been better for me to bring that hyperbolic secant squared 5x out front. Doesn't matter, same thing. Okay, so e to the blop times the derivative of the blop, and that's where you got to use the sheet. Okay. All right, that's a couple of pretty good examples. Ones I don't think that you did before. So let's call the next, oh, I've got another example. So look at me, 3 examples on derivatives. All right, so this is, we're still in topic 8. All right, let's say y is equal to 7x cubed times hyperbolic cosecant 2x. All right. Y prime, this is product rule, right? First times derivative of the second plus second times derivative of the first. Okay. 7x cubed, that's the first. The derivative of hyperbolic cosecant is minus hyperbolic cosecant hyperbolic cotangent. So times, let's put the times in there, minus hyperbolic cosecant 2x hyperbolic cotangent, or coth 2x, makes me think of goth, times derivative of the blop, a deuce. Okay, so putting this all together, 2 times 7, 14, and the negative, so it's going to be negative 14 x cubed hyperbolic cosecant 2x hyperbolic cotangent 2x. All right. That is first times the derivative of the second plus the second. So that took a lot. First times derivative of the second was that. The second hyperbolic cosecant 2x times the derivative of the first, 21x squared. All right, so you can, if you want, it would probably look better if we brought that 21x squared out front. All right, so, but I'm not going to rewrite it just to do that. Look at that. Now that looks a lot worse. This would scare the children if it were on the board. That looks like a lot worse than it actually was. So first times the derivative of the second, and that's all that jazz, plus the second hyperbolic cosecant 2x times the derivative of the first, 21x squared. Okay, also maybe you want to practice one using the quotient rule. So I just did the chain rule and the product rule. So maybe the quotient rule. Remember, bottom times root of the top minus top times root of the bottom all over the bottom squared. Try one of those. All right, topic number 9. Nueve in Spanish, I think. All right, hyperbolic antiderivatives. All right, and this is going to be, you're going to do U substitution, and you're going to use the sheet. Again and again and again, use the sheet. Okay, we're just going to do one example here. Let's take the antiderivative of hyperbolic cosecant squared 5x dx. U is going to be 5x. du would be 5 dx. So a fifth of a do would be dx. So we can rewrite this in terms of u, 1/5 out front, hyperbolic cosecant squared u du. What's the antiderivative of that? I don't know. Let me check. Boom. Minus coth x, hyperbolic cotangent, plus c. All right. So that's going to be minus 1/5 hyperbolic cotangent squared. Oh, no, it's not squared, is it? Let's look again. It is not squared. I don't think. Yeah, it's just hyperbolic cotangent of u plus c. You put u in the problem, you got to take u back out. Minus 1/5 hyperbolic cotangent 5x plus c. Could you check? Could you check? Could you check? Could you check? Yes, you could. Take the derivative of that. You know how to take the derivatives. Got my arm in the way of the screen. Use these guys. All right. Go the other direction. That's topic 9. Let's go to topic number 10. And this section will be finito. All right, topic 10 is inverse hyperbolic derivatives. Goodness gracious. Would anyone take calculus if all of this was on the board with no explanation of that, it's really not that bad? You're going to use the formulas, use the sheet. Now, if I made you memorize all this, would anyone take calculus? No. I'm not going to memorize it either. That would be dumb. All right. You may have a teacher that makes you memorize them in the future, however, but I hope not. Okay, our example for this. Exemple. We're going to find y prime if y is equal to inverse. So you got to look for that -1 so you know what you're doing. Inverse hyperbolic secant 2x squared minus 4. All right, so with these, you're just doing the u and the u prime, and we're going to use this formula right here. So not that bad. U is 2x squared minus 4. U prime 4x. All right, the formula, y prime. Okay, looking at the formula here. Negative u prime. So negative 4x over u. Okay, that's 2x squared minus 4 times the square root of 1 minus u squared. 1 minus 2x squared minus 4 all squared. All right, be neat for me, okay? Don't get things monkeyed around. Take your time. Write it nice and neat so I can tell what the heck's going on with your answer. Last thing I want to say, asterisk. Be careful. Exclamation. I won't put 2 exclamations, just 1. Be careful. Since you will be given a formula sheet, errors will be punished. All right, what do I mean by that? You're going to get less partial credit than normal on problems like this where it's just a matter of plugging into the formula. So if you look at it wrong and plug in wrong, I might not be quite as generous as I have been in the past. So be careful. Take your time. You can finish this test within the time limit, no problem. Don't rush. Double check. Okay, double check. It's like sabre, saber. All right. The arrowhead phone. All right. What was it? The bed bugs. Dwight got Jim out of a fix, right, with the whole bed bug thing and all that. So there you go. So that does it, 5.8 through 5.10. And I will talk to you next time.